Welcome to our exploration of scalable deep linking architecture for Android apps. In today's digital landscape, deep linking has evolved far beyond simple URI mapping. For large-scale, modular Android applications, a robust deep linking system is essential. It must handle everything from complex backstack construction to dynamic feature loading and strict security validation. This video will guide you through the key concepts, challenges, and solutions for architecting advanced deep linking in large Android projects. Let's start by understanding why traditional deep linking approaches often fall short as your app grows. Deep linking started as a simple way to map URIs to specific screens within an app. However, as Android apps have grown in size and complexity, the requirements for deep linking have expanded. Modern apps need to manage multiple feature modules, complex navigation flows, and strict security requirements. This evolution means that deep linking is no longer just a convenience, it's a foundational part of your app's infrastructure. In the next section, we'll discuss why traditional deep linking methods struggle to keep up with these demands. As your Android app grows, traditional deep linking approaches begin to show their limitations. Relying solely on intent filter declarations and direct activity launches works for small apps, but quickly becomes unmanageable. With more screens, feature modules, and authentication rules, maintaining consistency and security becomes a challenge. Scattered logic leads to inconsistent backstack states and potential security vulnerabilities. To address these issues, a centralized and scalable architecture is needed. Next, we'll look at the core components of such an architecture. Without a centralized deep linking architecture, logic becomes scattered across your codebase. This makes it difficult to maintain, test, and secure your app as it grows. Centralization brings all deep linking logic into a single, manageable pipeline. This approach ensures consistent handling of navigation, authentication, and authorization across all modules. By centralizing, you also make your system more testable and easier to update as requirements change. Let's explore how to build this kind of routing pipeline. At scale, deep linking should be treated as a routing pipeline. This means decoupling the incoming URI from the final screen transition. By doing so, you gain the flexibility to validate, authorize, and route requests dynamically. The routing pipeline acts as the backbone of your deep linking architecture, ensuring that every request is handled consistently and securely. In the following scenes, we'll break down the key stages of this pipeline and how they contribute to a robust system. The deep linking process begins with an incoming intent, typically triggered by a URI. This intent serves as the entry point into your app's navigation system. By capturing and parsing the intent, you can extract valuable information about the user's desired destination and any associated parameters. Handling this stage correctly is crucial for ensuring that the rest of the pipeline functions smoothly. Next, the intent is passed to the RouteParser for further processing. The RouteParser is responsible for interpreting the incoming intent and mapping it to a typed route. This step transforms raw URI data into a structured format that your app can understand. By using a RouteParser, you separate parsing logic from navigation logic, making your system more modular and testable. The parsed route is then ready for further validation and authorization checks before any navigation occurs. Once the RouteParser has done its job, you have a typed route that clearly defines the target screen and any required parameters. This abstraction allows your app to handle navigation in a consistent way, regardless of how the deep link was triggered. Typed routes make it easier to manage navigation logic, especially as your app grows and new features are added. The next step is to apply route guards for security and validation. Route guards are essential for securing your deep linking pipeline. They act as checkpoints that validate and authorize each navigation request. Common route guards include authentication checks, authorization rules, and feature flag validation. By centralizing these checks, you ensure that only valid and authorized requests are allowed to proceed. This approach greatly reduces the risk of security vulnerabilities and inconsistent user experiences. The authentication guard is the first line of defense in your routing pipeline. It checks whether the user is logged in before allowing access to protected screens. If the user is not authenticated, the system can redirect them to a login screen or display an appropriate message. This ensures that sensitive features are only accessible to authorized users, maintaining the security and integrity of your app. Beyond authentication, the authorization guard ensures that users have the necessary permissions to access specific features or data. This is especially important in enterprise or multi-role applications. By implementing authorization checks in your routing pipeline, you can enforce fine-grained access control and prevent unauthorized actions. This layer of security is critical for maintaining trust and compliance in your app. Large-scale Android apps often use dynamic feature modules to reduce app size and improve performance. Your deep linking architecture should support loading these modules on demand. When a deep link targets a feature that isn't currently loaded, the system can fetch and initialize the module automatically. This approach keeps your app lightweight while still providing access to a wide range of features. Proper backstack management is crucial for a seamless user experience. When handling deep links, your architecture should construct the backstack in a way that feels natural to users. This means recreating the expected navigation history, even when entering the app from an external link. By managing the backstack centrally, you avoid navigation inconsistencies and ensure users can navigate back smoothly. Scalable deep linking system must be testable and decoupled from the Android framework. By separating parsing, validation, and navigation logic, you make it easier to write unit tests and maintain your code. Decoupling also allows you to update or replace individual components without affecting the entire system. This flexibility is key to building robust, long-lasting Android apps. No system is perfect, and errors will occur. Your deep linking architecture should handle errors gracefully, providing clear feedback to users and developers. Common errors include invalid URIs, missing modules, or failed authentication. By centralizing error handling, you can ensure consistent behavior and make debugging easier. This also improves the overall user experience by preventing crashes and confusion. Security is a top priority in any large-scale app. Your deep linking pipeline should include strict validation at every stage. This means checking for valid URIs, verifying user authentication, and enforcing authorization rules. By building security into your architecture, you reduce the risk of vulnerabilities and protect both your users and your business. To maximize testability and flexibility, your deep linking system should be decoupled from the Android framework as much as possible. This means using interfaces and abstractions for navigation, parsing, and validation. By doing so, you can test your logic independently and adapt to changes in the Android platform more easily. Decoupling also makes it easier to share code across different platforms or app variants. A well-designed deep linking architecture ensures a consistent user experience, no matter how users enter your app. Whether they tap a notification, scan a QR code, or click a web link, the navigation flow should feel seamless. Consistency builds trust and makes your app more enjoyable to use. Centralized routing and backstack management are key to achieving this goal. Modern Android apps are often built using modular architectures. Your deep linking system should support this by allowing each module to define its own routes and guards. Centralized coordination ensures that all modules work together smoothly, while still allowing for independent development and testing. This modular approach scales well as your app grows. Dynamic routing allows your app to adapt to different user states and contexts. For example, you can route users to different screens based on their authentication status or feature availability. This flexibility is essential for providing personalized experiences and supporting complex business logic. By centralizing routing decisions, you maintain control and consistency across your app. Feature flags are a powerful tool for controlling access to new or experimental features. Integrating feature flag checks into your deep linking pipeline allows you to enable or disable features dynamically. This is especially useful for A/B testing, gradual rollouts, or restricting access to beta features. Centralized feature flag management keeps your app flexible and responsive to changing requirements. Tracking deep link usage is essential for understanding user behavior and diagnosing issues. By integrating analytics and monitoring into your routing pipeline, you can collect valuable data on how users interact with your app. This information helps you optimize navigation flows, identify popular features, and detect problems early. Centralized analytics make it easier to maintain and improve your app over time. Testing is a critical part of any deep linking architecture. Automated tests ensure that your routing pipeline handles all possible scenarios, including edge cases and error conditions. By writing comprehensive tests for parsing, validation, and navigation, you can catch bugs early and maintain high code quality. Testability is one of the main benefits of a decoupled, modular system. As your app continues to grow, maintaining scalability becomes increasingly important. A well-architected deep linking system can handle an expanding number of screens, modules, and navigation rules without becoming unwieldy. By focusing on modularity, centralization, and testability, you ensure that your app remains maintainable and performant over time. A scalable deep linking architecture isn't just good for users, it's also great for developers. Centralized logic, modular components, and clear interfaces make it easier to onboard new team members and collaborate effectively. Developers can focus on building features rather than wrestling with navigation bugs or security issues. This leads to faster development cycles and higher quality apps. Clear documentation and coding standards are essential for maintaining a scalable deep linking system. By documenting your routing pipeline, route definitions, and guard logic, you make it easier for current and future developers to understand and extend your system. Standards ensure consistency and reduce the risk of errors as your team grows. A great deep linking architecture is never truly finished. As your app evolves, so should your routing pipeline. Regularly reviewing and updating your architecture ensures that it continues to meet your needs and adapts to new challenges. Continuous improvement is the key to long-term success in large-scale Android development. Let's consider a case study of a large-scale Android app with multiple feature modules and millions of users. By implementing a centralized deep linking pipeline, the development team was able to manage complex navigation flows, enforce strict security rules, and support dynamic feature loading. The result was a more maintainable, secure, and user-friendly app that could scale with the business. Industry leaders recommend several best practices for deep linking in large-scale Android apps. These include centralizing routing logic, using typed routes, implementing comprehensive guards, and supporting modularization. Following these practices helps you build robust, maintainable, and secure navigation systems that can grow with your app. There are many resources available to help you master advanced deep linking techniques. Online courses, technical blogs, and open-source projects provide valuable insights and practical examples. By staying up to date with the latest trends and tools, you can continually improve your skills and keep your app at the cutting edge. The Android development community is a great source of support and inspiration. By collaborating with other developers, sharing your experiences, and contributing to open-source projects, you can learn new techniques and solve common challenges. Community involvement accelerates your growth and helps you stay motivated. Deep linking is constantly evolving, with new trends emerging in navigation, modularization, and security. Keeping an eye on future developments ensures that your architecture remains relevant and effective. Technologies like Jetpack Compose and dynamic feature delivery are shaping the next generation of Android apps. Staying informed helps you anticipate changes and adapt proactively. Let's recap the key concepts we've covered. Scalable deep linking requires a centralized routing pipeline, modular architecture, strict security validation, and support for dynamic features. By following industry best practices and continuously improving your system, you can build Android apps that are both powerful and maintainable. These principles form the foundation of advanced deep linking architecture. A robust deep linking system directly benefits your users. They enjoy seamless navigation, consistent experiences, and secure access to features. By investing in scalable architecture, you create an app that users trust and love to use. User satisfaction is the ultimate measure of your success as a developer. Developers also gain significant advantages from a well-architected deep linking system. Centralized logic, modular components, and clear interfaces make development faster and less error-prone. Teams can scale more easily, onboard new members quickly, and focus on delivering value rather than fixing navigation bugs. Despite the benefits, there are common pitfalls to avoid when building a deep linking system. These include scattering logic across modules, neglecting security checks, and failing to handle errors gracefully. By being aware of these challenges, you can design a more robust and maintainable architecture from the start. There are several tools and libraries available to help you implement advanced deep linking. Popular options include Jetpack Navigation, Deep Link Dispatch, and custom routing frameworks. Choosing the right tools for your project can save time and reduce complexity. Evaluate each option based on your app's specific needs and constraints. Deep linking often involves integration with external systems, such as web services, authentication providers, and analytics platforms. Your architecture should be flexible enough to handle these integrations without introducing tight coupling or security risks. Well-defined interfaces and centralized coordination make integration smoother and more reliable. Users can enter your app from many different sources, including notifications, web links, and QR codes. Your deep linking system should support all these entry points seamlessly. By centralizing entry point handling, you ensure that users always land in the right place, no matter how they start their journey. Accessibility is an important aspect of app design. Your deep linking architecture should ensure that all users, including those with disabilities, can navigate your app easily. This includes supporting screen readers, clear navigation cues, and accessible error messages. Inclusive design benefits everyone and expands your app's reach. Performance is critical in large-scale apps. Your deep linking system should be optimized to minimize latency and resource usage. This includes efficient parsing, lazy loading of modules, and avoiding unnecessary computations. Regular profiling and optimization keep your app fast and responsive. As your app evolves, you may need to update or migrate your deep linking routes. Supporting versioning and migration ensures that old links continue to work and users aren't disrupted. Plan for backward compatibility and provide clear migration paths to keep your app stable during updates. Proactive monitoring and alerting help you detect and resolve issues before they impact users. Integrate monitoring tools into your deep linking pipeline to track errors, performance, and usage patterns. Set up alerts for critical issues so your team can respond quickly and maintain a high-quality user experience. In summary, architecting advanced deep linking for large-scale Android apps requires careful planning, modular design, and centralized control. By following best practices and continuously improving your system, you can deliver seamless, secure, and scalable navigation experiences. Remember, the key to success is balancing flexibility, security, and maintainability as your app grows. Thank you for joining this deep dive into scalable Android deep linking architecture. As you move forward, consider how these principles can be applied to your own projects. Stay curious, keep learning, and continue building robust, user-friendly apps. The world of Android development is always evolving, and with the right architecture, your apps can evolve with it.